Hey guys, this is Mr. Schmidt. We're going to do a little lesson on how can we find irrational roots by completing the square. I apologize, I just could not get my hand angled properly without blocking everything, so I just pre-wrote everything, and I'll slide things down in points so it doesn't block you as much. Alright, so let's start off with finding rational roots, which is something we've done before. Okay, in the first section here, you'll notice that we have a quadratic equation. This could be solved by greatest common factor by pulling out an x plus 6, and then we get 0 and negative 6. These are considered rational roots because we have integer values. Over here, this one would be considered a dots method of factoring because we've got our perfect squares. So if we factor this 2x plus 7, 2x minus 7 equals 0. Set them both equal to 0. You wind up getting negative 7 over 2 and positive 7 over 2. These are considered rational roots because they're fractional, or if you were to divide them, they would be decimals that end, such as, what would that be, 3.5 and negative 3.5. Over here we have a basic trinomial, which we could factor x plus 15, x minus 3, so negative 15 and positive 3. Those are integer values. That makes them rational. Okay, so by definition, rational roots are simply roots that will consist of integer values, fractions or decimals that terminate or repeat. Now, will everything always fit into that category? Absolutely not. So here's a situation of one that won't. So let me just slide my paper a little bit. Oh, I guess somebody's calling us. Alright, so for this guy here, we have x squared plus 8x minus 3 equals 0. If you notice, if we tried to factor this trinomial, negative 1 and 3, 1 and negative 3, neither of those combinations will give us the 8 that we need in the middle. They both multiply negative 3, but it doesn't get me the 8. So in this case, this is not factorable. And here's what we do instead. Okay, we have our equation, and we're going to move the constant over to the right side. So we add 3 over, and that gives me x squared plus 8x equals 3. Now it's time to start completing the square. So this is where we're going to put our plus blank and minus blank after the 8x. And to complete the square, we want to take half of the 8, which is 4. 4 squared is 16. So we put the 16 into each of those two spots. And now I'm going to move that 16, this guy here, to the other side by adding it on over. When I do that, it gives me a 19, and with this trinomial, this can now be factored into x plus 4 and x minus 4. Since there's two of them, we can simply just write it as x plus 4 squared equals 19. To get rid of the squared, we would do the inverse or opposite operation, which is find the square root of both sides. Now when we do this, 19 is not a perfect square, nor can we pull any perfect squares out of it. So I just bring it over here. But you might be noticing I threw a plus and minus in front of that radical. The reason why I did that is, using this technique, for quadratics we must get two answers. In order to get two answers, we have to consider the positive and negative values in front of the square root sign. So always put that plus minus in front when you're doing the square root of that piece. Alright, now if we subtract the 4 over to get x by itself, here are the two irrational roots. Negative 4 plus rad 19, negative 4 minus rad 19. We can combine it like that in one step, but really it's one root like this and one root like that. Now, these probably don't mean a heck of a lot to you. That's because they're irrational. So if you wanted to get an approximation or for a feel of what it really is, I put these into the calculator, and you'll see these decimals over here. Okay. Notice how there's nothing that repeats, nothing that ends. That's why that's considered an irrational value. So about 0.358 and negative 8.358. Okay, approximately speaking there. Now, a way to check this if you wanted to on your calculator, let me just get this set up. me zoom in a little bit. Okay, so that's a little snowy looking there. If I press graph, there's my parabola. Now if I want to approximate these roots, you go to second calc, or second trace, choose number 2 for 0, and let's see, I'll go for my first guy over here, press enter once, move to the right, enter, enter, and notice, I'll try to zoom in a little more for you, notice that the value is about 0.358, which is the same value we got when I put in the calculator. And to go for the other root, second trace, number 2 again, got to go all the way back here, way back. Okay, press enter on the left side, enter on the right side, and if I zoom in on that for you a little bit, you'll notice you see the negative 8.35 and all those numbers. So we just did algebraically what the calculator did graphically. We approximated where these two roots would be since they were not integer values or rational values. All right, let me show you another example. Okay, so there's our next example. So for this one here, there's nothing that multiplies to a 36 that will also give me a negative 14. All right, so for this one here, we're going to start off by subtracting that 36 from both sides, which now gives you x squared minus 14x equals negative 36. We're going to complete the square by putting our plus blank and minus blank after the 14x. If we take half of negative 14 is negative 7. Negative 7 times negative 7 makes 49. So that's the number for the spaces. So plus 49 minus 49. And now what we want to do is we want to move this 49 to the other side. So I'm going to add that on over. And negative 36 and 49 gives me a 13. Okay. This trinomial will now factor. Let me just slide everything up for you guys. Okay. So this now factors into x minus 7 times x minus 7 equals 13. Since we have two of them, I'm just going to write it to the second power. Now we're going to take the square root of both sides to get rid of this squared. And once again, 13 is not a perfect square. We can't pull a perfect square out of it, so it's going to leave it alone. And that now leaves me with x minus 7. The radical and the squared canceled each other out. And remember, to get those two answers, got to put a plus and a minus in front of that radical. Okay, that's kind of, different, but got to put that plus minus in front there. And last step, just get the x by itself by adding over 7. And here you go. 7 plus or minus radical 13. That would be the irrational answers for the roots. And we can combine the two answers simply by putting plus minus. You don't have to break it up or separate it. All right, one last example. Okay. So for this one here, we got ourselves x squared plus 6x minus 41 equals 0. Let's add that 41 over. Now we're going to complete the square. So half of 6 is 3. 3 squared is 9. So we got the plus 9 and the minus 9. We're going to move this 9 over here to the other side by adding it. That now gives us x squared plus 6x plus 9 equals 50. You can now factor that trinomial into x plus 3 and x plus 3. And write it as x plus 3 squared equals 50. When we take the square root of both sides, something special about 50. This can be simplified. So I'm going to put the plus minus in front for the moment. And on the side here, I broke down radical 50. Think about what's the largest perfect square that goes into 50. Okay, 25 and 2, which then becomes 5 rad 2. And I just realized I was totally out of your view. Let me move the camera. There we go. Sorry about that, guys. So that is rad 50, which breaks into 25 and 2. Square root of 25 is 5. Alright, back to the action here. To finish this on up, we're just going to subtract the 3 over, and we get negative 3 plus or minus 5 rad 2, which is the simplified form of rad 50. And the problem is done. In the event that you needed a decimal approximation, then what you could simply do is you could put each of those, whoops, sorry about that. You could put each one of these individually into your calculator and just work it out. As you can see, these decimals do not repeat, they do not end. That's why these are considered irrational. Alright, so hopefully that helps you out on completing the square to find the roots when you can't factor in an equation. Thank you. Have a good day.